Welcome to Physical Science. Today we're moving on from the scientific method and we're moving into things that matter. Pun intended. So let's get right to it. Matter is really anything that has mass and takes up space. Yes, it has to take up space. And it has to be massful. Is that even a word? I don't see it on the word wall. We'll use it today. So mass is the amount of matter that is found in an object. And on Earth, mass is the same as weight. Not that it means the same, but that it's when you measure each, it comes out to being the same. So mass is the same as weight in that sense. Now volume we need to understand that term as well, because volume is a little bit different than mass and weight. It's not how much it weighs or how much force gravity is exerting on it. It's really about the amount of three-dimensional space that something takes up. So think of a basketball. It takes up three-dimensional space. Or a football, right? It's football season. Gotta love them Steelers. Go Steelers. Hope you're a Steelers fan. So a football takes up space. We take up three-dimensional space. We have height, we have width, we have depth, right? So we call it three-dimensional because there's three things that we can measure. Now a piece of paper seems like it's more of a two-dimensional space, but it actually does have a depth, a thickness, right? It's just very, very, very thin. Paper thin, we call it, right? Super thin. So it seems like it's two-dimensional. But when you draw a picture on a piece of paper, that picture itself is two-dimensional. It doesn't take up any depth. It only takes up width and length, or width and height. It doesn't take up any depth. But if you make a sculpture of something, of the same thing you drew a picture of, that sculpture would take up three-dimensional space because it would have height, width, and depth. So the question is, do you have mass? Well, of course you do, because we said it's basically the same thing as weight. And do you take up space? Well, most definitely you take up space, because if I want to put a book on a chair and you're sitting on the chair, you're taking up that space and I can't put my book down. So if those two things are true, then are you matter? Yep, you matter. See what I did there? All right, so what about your desk? Does it have mass? Well, sure it does. Does it take up space? Most definitely takes up space as well. And so is it matter? Yep, it is matter. What about the air, right? We're breathing it in. Try it with me. It feels really good to take a deep breath. Take a deep breath. And let it out. No, this isn't yoga class. Enough of that. So air, does it have mass? Well, yes, it does have mass. Because if you break it up into its component atoms, you have mass. Each atom, each element that we are aware of has mass. Does air take up space? Sure, it can keep changing the space that it's taking up, and it can change shapes, but it most definitely takes up space. Therefore, it is matter, indeed. Let's try another one. How about your dream? Did you have a dream last night? What was it? No, don't tell me. I'm afraid to go in there. I'm not sure I want to know what you dreamt about. Well, I know that you don't want to know what I dreamt about. Maybe your dream is okay. I have this recurring dream where I'm at my aunt and uncle's house when I'm a kid, and there's this black car with some mafia-looking guys in it, and they're trying to run me over with their car. And so they're speeding up at me, and I jump between these two trees that were at the end of my aunt and uncle's driveway, and it was one tree, but it split at the bottom and looked like two trees, and I jumped between those two trees, and the car would smash into the trees and not hit me. And that was it. That was the whole dream. I just told you the whole dream. And I had it like probably 20 times over my lifetime. Very strange. So does your dream have mass? No, no, no. It doesn't have mass. Nope. Does it take up space? Well, some might posit that dreams take up space in your brain, right? Because you're thinking about it. But that's not really space. So definitely doesn't take up space. So are dreams matter? I'm afraid not. I hope you said nah or no. Either one would have been correct. Yeah. All right, let's try one last one. The computer screen that you're looking at right now, does it have mass? Sure, it has mass. We all know that. It weighs something. It's a little bit heavy to pick up. Maybe not for you because you're strong, young and strong, able to pick things up, able to leap over buildings in a single bound. I know. You're a superhero. No doubt about it. Do superheroes take up space? Yes. Well, what about computer screens? Well, yeah, they do too. Definitely taking up space, right? You're looking at it. So is it matter? Of course it's matter. So you're going to do some problems just like this in the lesson today when you get to the independent practice. So I wanted to go over some of those with you. Let's see, what else can we go over together? Let's go over the states of matter, right? So there are three different types of matter that we find, right? Three different types of matter. We call these the states of matter. Sounds like some high political office or something. But it's really just the states of matter, like whether they are either solid, liquid, or gas. And you've probably seen these before. I'm almost certain in your previous science classes you've encountered these terms. So when we try to figure out whether a substance is in a particular state of matter, of being, so to speak, there are three factors that come into play. One of them is the shape. This is one of the factors that help us determine whether matter is a solid, a liquid, or a gas. One of the other factors that we look at is volume, and this will also help us determine the state of that matter. And thirdly are the particles and how they interact with each other. It tells us whether or not that matter is in a state of being solid, liquid, or gas. So let's define this a little more clearly. So when you look at the shape and you find that this substance is holding its shape, it stays the same, it doesn't move, it doesn't change shape, then you're probably dealing with a solid. However, if the substance is basically just taking the shape of whatever container it is, so if you pour it into a round container and it takes up the shape of the round container, and then you pour it into a square container and it takes up the shape of the square container, then you're probably dealing with a liquid. But if the shape is just able to change nilly-willy whenever it wants to, then you're dealing probably with a gas. So let's look at volume next, so we know the shape and what constitutes a solid, liquid, or gas in terms of shape. We can also look at the volume along with shape and get a better picture of what state our matter is in. So if our volume, and remember volume is the three-dimensional space that something takes up, so if the substance is taking up a fixed or definite space, the space that it's taking up doesn't change, then it's probably a solid, most likely, just like we thought in shape. Now, if the substance is taking up a fixed or definite shape, it could mean that it's a liquid. So this is why we need more than one factor to help us determine. Okay? So volume would be fixed for both solids and liquids. Okay, so that's where shape comes into play to help us determine which one we're dealing with, which state. Now, if the shape of the substance just changes willy-nilly, like it's floating freely, then you've got probably a gas. So the last factor we look at, and taking all these three factors together, we can determine the state of matter. We were going to look at particles and how they interact with one another. So if the particles are fixed, they're not moving past one another, they're not bouncing off of each other, or anything, they're just staying right where they're at, then you're dealing with a solid, sorry. You're probably dealing with a solid, right? But if the particles are able to slide past one another very easily, then we're probably dealing with a liquid. If, however, the substance is able to just kind of float around and do whatever it wants to do, and it's completely free, it's not kind of stuck to each other, they can slide past one another, they can spread apart from one another, they can come close together if they want to, they're basically floating freely, then you're probably dealing with a gas. So we look at all of these factors together, shape, volume, and particles, to make our final determination of whether or not our substance is a solid, a liquid, or a gas. So let's come up with some examples. So we already talked about a desk. Let's see if I can draw with the mouse here. Desk, that's a good example. How about an apple? What else? A phone. Now it looks like it's a desk phone from Apple. I'm not selling iPhones, just so you know. I had to write it weird. Phone. So what about a liquid? What's something that can slide past itself? Well, the particles can slide past each other. That would be, yeah, water's a good one. I had some milk on my cereal. That's another liquid. And, oh, what did I do? Oy, oy, oy. I don't, oh, erased everything. So you saw Now it's your turn. If you open up the file for the lesson for today, you'll find an independent or guided practice where you're going to complete 3 sections. The first section asks you to compare 2 objects, 2 things, and decide which has greater mass and which has greater volume. So, I'm going to do the first one with you, and then you can do the other 3. So, if you have an elephant and you have a mouse, which one has greater mass? Come on, this should be easy. If you said elephant, of course, that's correct. But which has greater volume? Ooh, it's perplexing. Well, if you said mouse, you were wrong. It's the elephant. Definitely has greater volume than the mouse. Takes up much more 3-dimensional space than a mouse does. At least any mouse I've ever seen, and any elephant I've ever seen. I've never seen a tiny baby miniature elephant that's the size of a mouse, nor have I ever seen a mouse the size of an elephant. I've seen some pretty big rats in New York City, but I've never seen them quite as big as an elephant. Mass and volume goes to the elephant. So you're going to do basketball and baseball. You're going to compare inflated balloon and baseball and bowling ball and basketball. You see, I like balls. I'm a sports guy. Are you a sports person? Maybe, maybe not. Doesn't matter. But you're going to compare those to determine which has greater mass, which has greater volume. And then you will get to a true-false section. And that is all yours. I think true or false, you've been doing those for long enough now. Pretty self-explanatory. Just go ahead and do that section. And then you'll get to the third section where they're going to ask you to determine the state of the matter of a few objects. And there's an example that I'll give you, and that's your desk. So if the shape of the desk is fixed, meaning it doesn't change, it's definite, it definitely doesn't change, and the volume is fixed, definite, meaning the volume of the desk doesn't change, it doesn't grow bigger or grow smaller, then you would say that is a solid object. So you're going to do the same for apple juice, wind, and a muffin. It's all yours. So take it away, have fun. Shouldn't take you long to do today's homework, and we'll keep going tomorrow. See you then.